Okay, so a little while ago I told my niece that she doesn't really need to worry about her double angle formulas, memorizing them. Well, not sine and cos anyways, because she can just use compound angle formulas. You need to know your compound angle formulas. But if you're talking about sine 2x, well, that's really just the sine of x plus x, because that's what 2x's mean. It just means x plus x. And this, you can see from your compound angle formula. Well, apply it. This turns into sine x cos x, because normally it's like a and b, but in this case they're both just x's, so both these things are x's, plus cos x sine x. Now, heard the word commutative before? It means they can be done in any order. This sine times cos is the same as cos times sine, so I can flip those around. This is equal to sine x cos x plus, well, sine x cos x. I just flipped the order of these two around. Multiplication works like that. 2 times 3, 6. 3 times 2, 6. Commutative. So I can flip the order around. So I just took these and went, because now they look the same. Now, how many of those do I have? Well, I have 2 of them. 2 sine x cos x. And there, you now have your double angle formula. That is a proof of the double angle formula using the compound angle formula. Sweetly. Okay, cos 2x equals cos of x plus x. I think you know where this is going. If you remember your compound angle formulas, which you better, cos x minus, because the sign switches in these ones, sine x equals cos squared x minus sine squared x. And that is the double angle formula for cos. Now, there's 3 different answers for this one because of the Pythagorean identity. I can take the fact that cos squared x plus sine squared x equals 1, and I can sub it in for either one of these. So this can turn, okay, wait, let's show that a little bit. Sine squared x plus cos squared x equals 1. Now, what I can do with that is I can rearrange it so I can bring things to the other side. So that means that cos squared x is equal to 1 minus sine squared x. Or I could bring the cos squared x over, so I get sine squared x equals 1 minus cos squared x. Now, if I use these things in this, it turns cos 2x into different things. Well, first of all, it turns it into 1 minus 2 sine squared x, because this cos squared x turns into 1 minus sine squared x. Now there's 2 of them. Or I can get, okay, this one I'm going to have to show. Cos squared x minus bracket 1 minus cos squared x. So use the Pythagorean identity on sine squared x, plug it into there. This then turns into minus minus cos turns into plus, so I have 2 of these, 2 cos squared x's minus 1. So this and this and this are all from cos 2x. But you don't need to memorize it. You can do that using your compound angle formula and Pythagorean identity. As for tan, you might want to just memorize that one. Or you can almost always, this sometimes doesn't help you, but tan 2x is equal to sine 2x over cos 2x. So if you switch it into this and then use these 2 identities, you should be able to get to this. Well, you should be able to get to the double angle formula for tan, but yeah, maybe that'll be crazy. I should try it.